Next question. Consider following information. Spot price of equity share is 75. Exercise price is 80 rupees. Rate of interest is 12%. Time period is 6 months. Standard deviation is 45%. Calculate call premium and put premium. Dear students, as the information is provided for the standard deviation, so we have to apply the Black and Scholes model for the purpose of premium calculation. I want you to do the first 5 steps on your own, then I will do answer. Chalo, read an answer along with me, friends. Step number 1. Calculation of revised spot price. Whether information for the dividend is given, not given. So let us ignore it. So not applicable. Step number 2, depreciation. Step number 2, calculation of e raised to negative RF into t. So e raised to negative RF is 12% and the time period is 6 months. E raised to negative 0.06. That is the way E factor will be found. So E raised to 0.06. So the answer is 0.94176. So 0.94176. That is the step number 2, e raised to negative RF into t. Step number 3, calculation of ln S divided by E. Now this can be calculated again by 2 methods. Spot divided by exercise, 75 upon 80. The answer is 0.9375. Then we will have Barman procedure. 10 base log table reading. In case of 10 base log table, it starts with 10. So it is 9375. So it is 93 and that's 7. So it is 93 and that's 7. And mean difference of 5. So it is 9717 plus 2. So it is 9719. We understand that the next is the Barman process. In that we can see that there is no digit before decimal. So 0 minus 1 is negative 1. So 0.9719 minus 1. So it is negative 0.0281. And the last is ln S divided by E. Negative 0.0281 into 2.303. So it is negative 0.0647143. This is the first method by which you can calculate ln S divided by E, or otherwise. Second process is S divided by E. So 75 upon 80. So it is 0.9375. Then it is under root for 12 times. One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 0.4 times 9, 8424, 364. Then deduct 1. So the answer comes to 0.4 times 0, 1575636. And lastly, ln S divided by E is negative 0.4 times 0, 1575636 into 4096. That comes to negative 0.064538. You may write, you may not write. So again you can see that there is a marginal difference. However, either of the answer is acceptable, and of course it is not going to have the huge impact on the D1 calculation. Step number 4. Calculation of D1. If it is ln S divided by E plus RF plus variance divided by 2 into time period divided by under root of the time period into standard deviation. I am taking this value negative 0.064538 plus RF is 12% plus variance is square of standard deviation, so square of 0.45 divided by 2 into time period is 6 divided by 12, whole divided by under root of the time period, so it is under root of 6 divided by 12 into standard deviation, that is 0.45. So let us see how to do answer. First of all, square of 0.45. So it is 0.2025 divided by 2. So 0.10125 plus 0.12. So this comes to 0.22125 into 0.50. Left hand side it is 0.064538 whole divided by root of 0.5. Root of 0.5 is 0.7071. So 0.7071 into 0.45. So 0.3182. This is the way we are required to make the calculation. So 0.22125 into 0.5. So 0.110625. Negative 0.064538 whole divided by 0.3182. That comes to 0.1448. That is the way the D1 will be found. Step number 5, calculation of ND1. For ND1 calculation, we have to read Z table 0.14 and 0.15. So D1 and Z table reading 0.14 and 0.15. So 0.14. So 0.0557 and 15 0.0596. This is the way there are reading. Will compute the difference. It is 0.01, then 0.0596 minus 0.0557. So 0.0039. Okay. So now the final answer is 0.0557 plus 0.0039 divided by 0.01 into 0.0048. So 0.0039 into 0.0048 upon 0.01. So 0.0557 plus 0.0019. 0.0557 plus 0.0019. So 0.0576. This is the way we have the reading from Z table of the D1 value. Since D1 is positive, so ND1 will be 0.5 plus 0.0576. So 0.5576. That is the way the ND1 will be found. So, step number 6. Calculation of D2. It will be found as D1 minus under root of time period into standard deviation. What is the value of the D1? Value of the D1 is 0.1448. Minus under root of the time period into standard deviation, that is 0.45. So root of 0.5 into 0.45. So 0.3182. 1448 minus 0.3182. So the answer is negative 0.1734. This is the way we can compute the answer. So let us see step number 7. Calculation of ND2. So D2 and Z table reading. So 0.17 and 0.18. So 0.17, 0.0675 and 18, 0714. Zero 0.0675, 0.0714. So 714 minus 675, that is 39. So 0.0039. And this is having a difference of 0.01. 0.0675 plus 0.0039 divided by 0.01 into, it is 1734, so we have to multiply it with 0.0034. 0.0675 plus 0.0039 into 0.0034 upon 0.01, so 0.0013. So 0.0675 plus 0.0013, so 0.0688. Now based on this, we'll compute the ND2 value. So ND2 is equal to 0.50 minus 0.0688. So it is 0.4312. Dear students, this time it is deducted. Why? Because the D2 value is negative. So the reading will be added if at all the value is positive, otherwise it would be deducted if it is negative. Next, step number 8. Calculation of call premium. Spot into ND1 minus exercise into ND2 into e raised to negative RF into T. What is the spot price of equity share? 75. What is ND1 value, friends? ND1 value is 0.5576. Minus exercise price is 80 into ND2 value is 0.4312 into e raised to negative RF into T. In a way that it is the discounting factor. The discounting factor is 0.94176. So 0.94176. 75 into 0.5576, that is 41.82, minus 80 into 0.4312 into 0.94176, 32.49. $41.82 minus 32.49, that is 9.33. That is where the call premium can be found. Now after making calculation of call premium, step number 9 is calculation of put premium. For put premium, it is like this. Value of put plus spot is equal to present value of exercise price plus value of call. So it is exercise price into e raised to negative RF into T plus value of call minus spot. Exercise price is 80 into e raised to negative RF, that is 0.12, into T time period is 6 divided by 12, plus value of call is 9 rupee 33 paise minus 75. So 80 into e raised to negative 0.06 plus 9.33 minus 75. So it is 80 into 0.94176 plus 9.33 minus 75. So 80 into 0.94176, product of both of them is 75.34 plus 9.33 minus 75. So the final answer is 9 rupees 67 paise. That is where the put premium can be found. Let us have a revision of the entire answer. Step number 1 not applicable, that is the revised spot price. Step number 2 is e raised to negative RF into T. Step number 3, ln is divided by E, that you can find by either of the method. You'll get approximately the same answer. D1, in that case, again, be sure that so you are clear with the sequence. This time the standard deviation is given to us. So we have to convert that first of all in variance for making calculation. Then calculation of ND1. So that the D1 value is having like the two readings. That is the way we have to consider it. Then ND1, the reading of the D1 will be added to 0.5. Why? Because the D1 is positive. Then D2, for that say D1 minus denominator value, and this reading would be deducted from 0.5. Why? Because the D1 value is negative. And with that, so the ND2 is calculated. Lastly, the call premium. For that, so the formula is spot into ND1 minus E into ND1 into E raised to negative RF into T. Put premium. For that, so we will apply the put call parity theorem. And with that, so the put premium is calculated 9 rupees 67 paise.